When an ion or a molecule is surrounded by solvent molecules, and this is arranged in a specific manner, this is called solvation. When your solvent is water and your solute consists of ions, it's stabilized by a process called hydration. Okay, so when ions are dissolved in water, ions are stabilized by hydration or ion dipole attractive forces. But the solvent and the ions are arranged in a specific manner. For example, if we have potassium bromide dissolved in water, potassium bromide is the ionic compound and water is your solvent. So what happens is at the surface of your potassium bromide crystal lattice, those ions are going to be taken away by the water molecules first. So if we look at potassium ion, it's going to be surrounded by the electronegative oxygen of water. And fluoride is going to be surrounded by the electropositive hydrogens of water. This arrangement keeps the ions stabilized in solution, and this process is called hydration. Our next topic is the heat needed to form a solution, and there's 3 steps in forming a solution. The first step is separating the solute into its constituent particles. The second is separating the solvent particles, making room between the solvent particles so that the solute can mix with the solvent. And the third part of the process is the mixing. Okay, so let's go through the first step, separating the solute into its constituent particles. So our solute particles look somewhat like this. Does it take energy, or does energy need to be lost for separation of the solute particles to occur? Okay, the answer is energy needs to be added to separate these solute particles. It's going to need energy to create space between the solute particles. Hence, this is an endothermic process. Because it's going to take energy to overcome the attractive forces between the solute particles. Okay, if you can remember from Chem 110, delta H represents the change in enthalpy. Enthalpy is the energy of a process per mole of the substance. So for a mole of the solute particles this delta H is going to be greater than 0. When your delta H is greater than 0, that's an endothermic process. It's going to take energy. Okay, the second part of the solution process is making room for the solute particles. So here I have a beaker of my solvent. Here I have a beaker of my solvent particles. That look more tightly packed. And then what I'm going to do is I'm going to create more room. Okay, to overcome those intermolecular forces between the solvent particles to make more room, that's going to cost some energy. Hence, this is also an endothermic process. Okay, your delta H will be also greater than 0 for your solvent. Okay, the last part of the solution process is, now that I've made room in between my solvent particles, I can go ahead and mix in my solute particles. This mixing process is going to release energy. This is an exothermic process. My delta H will be less than 0. Energy is going to be released for the solute particles to interact with the solvent particles through IMFs. Energy will be released for the solute particles to interact with the solvent particles. So overall, if we look at the whole delta H of solution process, the delta H of the solute is a negative process. It's going to release energy. It's going to gain energy. It's a positive process. It's going to gain energy. And the delta H of your solvent is also going to be an endothermic process. And your delta H of mixing is the only exothermic process. So delta H of solute and delta H of solvent are going to require energy, and delta H of your mixing process is negative. So what causes exothermic and endothermic reactions to occur? What causes these processes to release and absorb energy? An example where we see this are in cold packs and heating packs. Okay, cold packs, they're typically used to reduce inflammation, and how these operate is there's a solution of ammonium chloride. Ammonium chloride is dissolved in water, and what happens is it absorbs heat. It's an endothermic process. And Heating packs is another example where we see it's an exothermic process. Heating packs are used to relieve soreness, and oftentimes, so there's a chemical inside, there's a chemical mixing process that occurs. Usually it's with sodium acetate dissolved in water, or it's with calcium chloride in water that will release heat. What causes this to happen? Okay, and we're going to relate that using our delta H of solution. Okay, if we look at our delta H of solution up here, for this to be an exothermic process, the delta H of mixing has to be greater in magnitude than the delta H of solute and the delta H of your solvent. So if the sum of the delta H of solute and delta H of solvent is smaller in magnitude than delta H of mixing, which is exothermic, delta H of solution is negative. The process is exothermic. More energy is released in the mixing than the energy needed to break up the solute and the solvent particles.